Hi everyone. I was a bit confused. Am I live or not? Um, I'm a bit nervous but more excited because this is going to be my first talk ever. Just a brief introduction. I'm a new graduate. I did my master's in information system security from Concordia University of Edmonton. So while doing my research, I did some of the experiments, and the whole presentation today is going about the experiments which I performed while doing my research. So now I'm going to share my presentation with you. So today's presentation is all about ransomware analysis based on machine learning and Flare virtual machine. And today's agenda is about, firstly, briefly, we will introduce what is ransomware, what is machine learning, and how ransomware attack works, and the type of ransomware families we studied while doing our final research, followed by methodology, an outline of our experiments performed, and the most important things, the data set which we collected to perform our experiment, followed by discussion part and some of the interesting results which we achieved while doing those experiments, and then how we use the Flare virtual machine to perform the experiments, and then what attacks were performed to achieve the results. So the first question is, what is ransomware? Ransomware is a malware that prevents or limits users from accessing their system. It's like we are using our own system, but all of a sudden we are not able to use it. Probably it prevents our access or limits our access, or it can be locked. And if it encrypts all the file types, it is known as crypto ransomware. In that case, it forces users to pay ransom to decrypt the key. The recent study reports that ransomware attacks grew by 118%. New families of ransomware are detected, and threat actors use innovative techniques. There is an almost constant increase in business detections of ransomware, rising a shocking of 365% from last year to present year. Question is, which sectors are attacked by ransomware? While I cannot think about even a single sector which is not attacked by ransomware. Most of them are education, government, healthcare, HR departments, mobile devices, and Macs. How these sectors are actually attacked? By any attachment, which includes phishing email or spams or social engineering, sometimes drive-by downloads, or sometimes the advertisement which are shown on our screen and we just click it, but those are malware advertisements. Now, what is machine learning? Machine learning is a method of data analysis. This is a branch of artificial intelligence, and in this, systems learn from data. It helps to identify patterns, make decisions with minimal human intervention. There are different methods for the machine learning, which include supervised learning, which includes trained using labeled data, the one we used in our research. Other are unsupervised, semi-supervised, and reinforcement learning. Now, what is classification? Classification includes the predicting the class of a given data points. It is considered an instance of supervised learning, that is, learning where a training set of correctly identified observation is available. Sometimes classes are known as targets, labels, or categories that belongs to the category of supervised learning. The targets also provided with the input data. The first thing is infraction. Firstly, it has been delivered to the system via email attachment, phishing email, infected application, or other method. The ransomware installs itself on the endpoint and any network devices it can access. All of a sudden, we are working on our system and we download any attachment or any phishing email, hence our computer got infected. Once the infection is in our computer, what's the next point? The ransomware contacts with a command and control server, which is operated by the cyber criminals behind the attack to generate the cryptographic keys to be used on the local system. The next part is encryption. The ransomware starts encrypting any file that can be present on our local machine or even on the network. Once the file is called encrypted, it starts doing extortion. With the encryption work done, the ransomware displays instruction for extortion and ransom payment threatening destruction of data if payment is not made. We are using our own system and we are not able to use our system just because now it has been infected by a malware known as ransomware and it's asking us to unlock the computer. To unlock the computer, organizations either have to pay the ransom or hope for the cyber criminals to decrypt the affected files. Or sometimes they can attempt recovery by removing infected files and systems from the network and restoring data from clean backups. There are four families which we studied in our research. Those are WannaCry, Petya, Cerber, Dharma. All of these ransomware families comes under the category of crypto ransomware families. It is a very harmful program that encrypts files stored on a computer or mobile device in order to extort money. Then encryption scrambles the contents of the file so that it is unreadable. To restore it if it for normal use or a decryption key is needed to unscramble the file. There was a methodology which we used to present our experiments. It includes the collection of data. Ransomware samples were collected using virus total and hybrid analyzer to perform the experiments. There were two approaches which we used. The first one was malware samples, which are not classified from any antivirus vendors, and we use classifiers for the classification. And the second one was ransomware samples that are classified from antivirus providers to their respective families. Virus total and hybrid analyzer used to label our ransomware families while doing our experiments. Now, there were some steps followed to perform experiments. First step was collected dataset. To collect our dataset, we use virus total and hybrid analyzer to collect all the dataset. Once the dataset was collected, we use a behavior analysis by using grouping and filtering, by doing the grouping and filtering from our dataset. And then we do hashing by using SHA-256 or SHA-256. And then we save the data in Excel sheet in the format of ARFF or CSV because that was compatible to the tool we used. The tool which we used was the Weka tool that was configured to do the pre-processing of data. The best part about the Weka was to do the malware classification in data mining of data. There are so many classifiers in a Weka which we can use, but some of them what we used were SMO, naive Bayes, J48, random forest, and the last one, multi-layer perceptron. Especially classifiers are used to concrete implementation to, to implement the algorithm to get the results about the ransomware behavior analysis. Our dataset included WannaCry ransomware, Dharma ransomware, Cerber ransomware, and Petya ransomware. In a WannaCry, there were 15 samples. In Dharma, there were 11 samples. And in Cerber, we collected 11 samples again. And Petya, we collected 7 samples. So in all total, we got 55 features and 44 instances. That means it includes how many files got deleted, how many files are modified, how many files are added, or what were the infections. It doesn't only infect the files, but our registry things, library files, everything got affected as well. Now, after using the whole data set with 55 feature and 44 instances and different classifiers, we come to the end to some discussions. The first discussion part says the Weka machine learning tool has an option to allocate a percentage split of a data set for training and test purposes. Like we have a data set, we can divide the data set into two parts. The first one is for training, the other part is for testing. Then evaluated the performance using machine learning matrices. That includes true positive rate, false positive rate, precision, recall, F measure, and ROC area. The dataset created by extracting information from their attributes. Now the attribute includes how many files were opened, how many files were modified. For example, once a computer is infected, there were some changes. That includes how many files were dropped or deleted. There were some changes in the registry actions. Those were deleted or opened or modified. It also includes some of the changes in synchronization mechanisms and signals, which include mutexes created and mutexes deleted. That includes some of the network behavior changes, which includes HTTP, UDP, or TCP. And there were some changes in the library as well, which includes kernel, user32, etc. After doing the whole experiments, we come to the results like there were some classifiers which were way too good to understand the data and give us the better accuracy. One of them was J48 classification, which got a result of 97.73% accuracy rate. We use the same data to we split the same data for the testing and training, but J48 got really good accuracy as compared to the other classifiers. Random Forest was able to understand our data as well because it gives us 95.45% accuracy, which was good, but J48 was better than the other ones. Same SMO resulted in 86.64 and base network gives us 72.73% of accuracy. This is the same thing which we already discussed in our results part, but this is how our Veka tool shows us the results, like how we are getting J48 is getting 97.73% and how the other classifiers understand the behavior analysis of ransom. After performing and after working with the Veka tool, we come to know with a question like we have different families. For example, we studied about WannaCry, Server, Therma, and Pataya. We have one family and it has different members. Do different members work same as the same family? To know about that thing, we use Flare Virtual Machine. We rely on a customized virtual machine to perform malware analysis. The virtual machine is a Windows installation with numerous tweaks and tools to help our analysis. The best thing is that it is freely available and it is an open source Windows-based security which is designed for reverse engineers, malware analysis, incident responders, and penetration testers. We run ransomware samples on a same virtual machine containing same number of files, folders, documents, etc. as with same machine as it helps us to know the behavior of different members of same ransomware variants. In this technique or while doing these experiments, the first important thing was to isolate our virtual machine from the host machine. So to achieve that, we created one shared folder and after copying files from the host device to the virtual device, every time we remove the excess of the shared folders so that our host machine should not get affected by the malicious files. This is an interesting thing which we actually did. For example, the first screenshot shows the WannaCry attack. That's a sample one. When we actually run the malicious file of WannaCry attack, we come to know like actually 24 files were added, 71 files were deleted, and there were some changes in the registry entries as well. Some of them got updated, some of them got added. The best thing was we were using same data every time to know the behavior of a ransomware family more into details. So the WannaCry sample 2 gives us the completely different behavior because it added files in thousands, like 3,310. That was an interesting part. Even our registry entries got changed in thousand values. And moment the executable file was downloaded on my system, it gives me the option, oops, your file has been encrypted. And it gives you the options how you can recover your files. To recover your files, you need to pay. To pay, it will give you a proper address where you can send your money. After doing WannaCry ransomware samples running on our system, we run some of the samples of Petaya sample. When we do with that, it gives us the warning, do not turn off your PC. If you abort this process, you could destroy all of your data. Please ensure that your power cable is plugged in. At the end, if you will click again, after showing warning, it gives you the other page of showing like you need to pay the ransom to get your own data back. This was a very interesting Petaya sample which we ran on our system, because once I ran this sample on my system, it starts showing me like you are a victim of the Petaya ransomware, because the hard disks of your computer have been encrypted with the military grade. And the one I ran that sample on my computer, it asked me to press any key. The moment I pressed any key, it started beeping my computer so loud, like I was scared for a minute, like what's going on with my computer, because beeping was way too louder than actual volume of my computer. So in that case, it crashed my all virtual machine. So to do the other experiments, I downloaded the virtual machine again. It not only affected my virtual machine, it affected my host machine as well, even though those were completely isolated from each other. So to get rid of this problem, I actually put my system for 2 hours on charging, and after that, I was able to turn on my host computer. So this was very interesting sample which I ran on my computer. So after that, Dharma ransomware. In case of Dharma ransomware, the sample starts with map drives, which followed by the roots of operating system drive and encrypting files via implementation of AES algorithm. After encrypting all the files, the malware popped up ransom note. Your all files have been encrypted. And it gives you how to obtain bitcoins, how to decrypt your files. So it gives you the whole options. Coming towards the server ransomware, the most interesting thing about server ransomware is it doesn't show you like your computer is getting infected, because it runs silently in the background during the encryption phase and not provide any indication of infection to us. There are some ransomwares, the probably when we just do the click part of the executable file, it shows you the right away your computer has been encrypted. But the thing in server ransomware is like probably for so many hours or probably minutes, it's just run silently in the background. And during the encryption phase, it just indicate you once everything is done for its their end. This was the other sample of the server ransomware which we ran on our sample. Again, it shows us like your documents, photos, databases, other important files have been encrypted. Again, you need to pay the ransom to get your own data back. So at the end, like after doing the research about the behavior analysis and to study about the different families and the different members of a same family, we come to know how to defeat ransomware. Though I didn't do my research on how to defeat ransomware, but still there are some recommendations which we can share. And if I will get a chance to do it in the future, definitely I would like to know like how to defeat ransomware. So the first part is isolate the infection, which prevent the infection from spreading by separating the infected computers. Even in this, the best part is that to isolate the backup of our um, computer from the host machine. And the second one is identify the infection. From messages, evidence on the computer, identification tools, because when the ransomware happens on a computer, it tells you like this is a WannaCry ransomware on your computer and your files have been encrypted. So it gives you the evidence in the messages as well. So we can determine which malware strain we are dealing with. After that, if it's possible, we can report to the authorities to support and coordinate measures. And we can determine some options, which include there are a number of ways to deal with infection and determine which approach is the best one. And we need to restore and refresh, and we need to use safe backups and program and software sources to restore a computer or outfit a new platform. And we need to prevent occurrence. We need to make sure like what was the vulnerability in our system, like our computer got exploited or our computer got compromised or affected by the ransomware. What was the problem in this behind that? and we need to plan to prevent the reoccurrence so that it should not happen again with our system. So yeah, that was all about my presentation today. There is my email ID. If you have any question, you can ask me and you can email me, and definitely I will try my best to get back to you. And it will be so great if you will ask more questions and I can work on it and I can get back to you. I'm so thankful like that was my first talk and I'm getting so good comments. And thank you to all for listening to my talk. And I'm very thankful to you all.